Hi, my name is Carol Yan, and I'll be teaching you how to use the Solver extension on Excel. What it does, it helps you solve the linear optimization model, which basically helps you solve the maximum amount of your objects in order to maximize the output. So the problem that we'll be using is from one of my classes. Investment Advisors Inc. is a brokerage firm that manages stock portfolios for a number of clients. A particular portfolio consists of U shares of U.S. Oil and H shares of Hoover Steel. The annual return for U.S. Oil is $3 per share, and the annual return for Hoover Steel is $5 per share. U.S. Oil sells for $25 per share, and Hoover Steel sells for $50 per share. The portfolio has $80,000 to be invested. A risk index is used to control risk. The risk is 50 cents per share of U.S. Oil and 25 cents per share of Hoover Steel. The risk for the portfolio can be at most 700. In addition, the portfolio is limited to a maximum of 1,000 shares of U.S. Oil. So what we are going to do first is write out the formulation of a linear optimization model that will maximize the total annual return of the portfolio subject to the constraints. So what we're going to do first is we're going to label what is going to represent the number of shares for U.S. Oils and Hoover Steel. So let U be the number of shares of U.S. Oil, and let H be the number of shares of Hoover Steel. And so our objective function, we're going to find out what maximizes. Therefore, we're going to put max. And what we are going to find out is the total annual return. So over here, it tells us that the annual return for U.S. Oil is $3 per share, and the annual return for Hoover Steel is $5 per share. So we're going to put $3 for U.S. Oil plus $5 for Hoover Steel. That's our objective function to solve this problem. Now we're going to put the constraints, which basically means what we have to maximize in order to find what a number of shares for U.S. Oil and Hoover Steel is going to be. So subject to. So our first constraint is going to be this one over here. We're going to do $25 per share for U.S. Oil and $50 per share for Hoover Steel. And the maximum of dollars to be invested is going to be $80,000. So it's going to be 25U plus 50H is less than or equal to, because we want to find out any number that is smaller or equal to $80,000. Next, we are going to do the risk for the portfolio. So the risk is going to be 50 cents per share of U.S. Oil and 25 cents per share of Hoover Steel, and that at most will be 700. So 50 cents for U.S. Oil plus 25 cents for Hoover Steel is less than or equal to 700. Our next constraint is going to be this one right here. So we are limited to maximum of 1,000 shares for U.S. Oil. Since only U.S. Oil is for this constraint, we're just going to put U, and we're going to put less than or equal to 1,000 for 1,000 shares. And to make sure that everything is a positive number, we're going to put U and H is greater than or equal to 0. Now we're going to put this all in Excel format, which I have set up over here already. We're going to have the decision values right here, which basically will be where our answer is going to locate. This is the objective function, where we will put the $3 over here. to represent the per share as it is located right here, $3 per share and $5 per share. So we put 5 right here. And over here, we don't put anything, but we want to know the number of shares over here and what our total cost of annual return is going to be. So here you would put the formula of this times this plus this times this. And right now it's going to be 0 because we don't have anything here. But to find the total cost of annual return, we have to multiply the number of shares times the dollar per share, or $3 per share and $5 per share. Now we have the constraints over here, as you remember from here. So our first constraint is 25U plus 50H is less than or equal to 80,000. So 25, 50, and we're actually going to put our constraint or a maximum right here because this area is actually going to be where our number is going to be. So the number that is less than or equal to 80,000, and it will be multiplied from this to this as well. So this, we're going to put the number of shares of US Oil multiplied by 25 plus the number of shares for Hoover Steel multiplied by 50. And now we're going to do the same for the rest of the constraints. So 0.5U plus 0.25H is less or equal to 700. So we're going to put 0.5, 0.25, and our maximum is 700. And since we're going to use the same formula, we're going to drag it down. Or actually, don't forget to make sure that this stays the same for all the formulas down here. So we're going to put the dollar sign, and so that way these stay constant. And now all we got to do is drag the formula down. See here? Now we know that this will stay the same because of the dollar sign. The last one is going to be U is less than equal to 1,000 shares. So for this, we're going to put 1 just to represent US Oil and 0 to represent Hoover Steel. And since we're not using that, that's why it's 0. And now we're going to put 1,000. So now that you have all your data inserted and your formula is ready, you're going to click Solver, and you're going to set the objective to the total cost of annual return, and we will keep it at max because it's going to be the maximum. And the changing variable cells will be the number of shares for US Oil and Hoover Steel. And here we add the constraints. So for this, we will click on this and make sure it's less than equal to this, and then keep adding and do it for all of them. Click OK. And to make sure that everything's non-negative, we're going to click this, and we're going to choose Simplex LP. Now we're going to solve. And we're going to keep solver solution, okay? And that's how you find the maximum number of shares of US Oil and Hoover Steel. This is another way to analyze data because the data that we have is this right here as well as the constraints. And this is how we analyze to figure out the number of shares of US Oil and Hoover Steel. This is definitely a way to figure out the maximum output, and I feel it should be utilized in our class as well. Thank you.